Achieving a desirable crop stand in no-till conditions can be challenging at times for producers. By evaluating their residue management techniques and seeding equipment, producers will likely see an improvement in crop yields. This video will identify strategies needed to properly place the crop seed in no-till conditions. Seeding equipment needs vary drastically between no-till and conventional tillage systems. However, optimum environmental conditions needed for proper seed growth and development remain the same regardless of the tillage system. Residue management needs to begin at harvest time of the previous year's crop. Large combines with wide heads, as now designed in most cases, cannot adequately spread straw and chaff the full width of the header with standard setups. A large part of the difficulties encountered when seeding in no-till systems can be traced directly to inadequate spreading of crop residues and chaff. Optional and aftermarket equipment is available to improve performance, and it should be considered a necessity. Take time when setting the combine to assure that the straw chopper and chaff spreader are set correctly. It could save you substantial time, effort, money, and problems later. Also, increasing the cut height of the stubble or the use of a stripper header will reduce the amount of straw that will need to be spread. A heavy harrowing perpendicular to the direction of combining is the best alternative if straw spreading is less than ideal at harvest, such as with adverse wind conditions. But harrowing is a poor substitute for proper equipment on the combine. If harrowing is done soon after harvest, straw spread is better, but snow catch is decreased. In the spring, harrowing is ineffective because the straw has settled and it's difficult to move. The time to spread chaff is behind the combine with a chaff spreader because it's too fine to spread with other equipment. Now that we have discussed residue management, let's address proper seeding equipment that places seed in a no-till environment. It would be futile to attempt to discuss each type of seeder on the market and all the options available for each. No-till requires entirely different seeding equipment and methods than what were previously employed in conventional tillage or even minimum tillage systems. No-till seeding equipment must be able to handle wet soils, heavy residue, and soils that have structure. For example, soils no longer fluffed with tillage. This video focuses on no-till seeders and seeder attachments that place the seed securely into firm, moist soil and covers it with loose material. The firm, moist soil maximizes movement of water to the seed. Covering with loose soil prevents the seed zone from drying and allows the shoot to emerge with minimum mechanical resistance. Placing loose soil over the seed allows crops such as corn to place its growing point at the proper depth. These conditions need to be met independent of the tillage system. The equipment necessary to do this job in no-till is quite different than those used with conventional tillage. In conventional systems, one of the primary goals of tillage operations is to create conditions necessary for seed openers to work properly. This involves creating a seed bed which is firm and moist at desired seeding depth, covered by a layer of dry, loose material. In no-till, the surface soil layer is always firm and can be quite moist to wet at times. If attempts are made to use the same seed opener designs as with conventional tillage, failure occurs for numerous reasons. The first failure occurs because these seed openers have trouble cutting or clearing the residue. Secondly, they will lack depth control since seeding depth was controlled in large part by secondary tillage. Thirdly, they will normally cause excessive disturbance when the soil is moist or wet because they were designed to operate in the dry soil layer. And finally, the packing mechanism of conventional seeders will overpack the soil on top of the seed, fail to press the seed into firm soil, compact the area to the side and below the seed, or leave the seed slot open. The type of failure which occurs depends on closing system design, soil type, and moisture conditions. All are due to the fact that these systems were designed to work where surface conditions are loose and dry, or at least loose. In evaluating no-till seeders, it is helpful to again review the requirements of the seed. Seeds need to be pressed into firm, moist soil at the proper depth and covered with loose material. Every no-till seeder must be able to do the following with minimal soil disturbance. Number 1, cut and move residue when desired. Number 2, open the seed furrow. Number 3, meter the seed accurately and uniformly. Number 4, maintain accurate depth. Number 5, place the seed in the furrow. Number 6, press the seed tightly into the bottom of the slot. And number 7, cover the seed with loose material. Hairpinning is a much greater problem when following small grains with another small grain or with a small seeded crop. In these heavy residue situations, it sometimes is advisable to straighten the straw or move some of it from the row area in front of the disc openers. This process is called residue managing. Commercially available attachments designed somewhat like small side delivery rake wheels have been available for row crop planters for a number of years. They are now being designed for use on drills as well, but are less effective due to the absence of a parallel linkage system on most drills. The philosophy behind these attachments is to move some of the residue from the row area without disturbing the soil. This allows disc openers to operate without hairpinning even under tough conditions. Starter fertilizer openers, or coulters, are sometimes used to cut the residue ahead of or at the same time residue managers move the residue from the row area. In many, if not most, no-till conditions, fertilizer openers need to have a scraper wheel or skid beside the disc blade to keep the soil from lifting or rooster tailing and balling up the seed opener's gauge wheels and or closing wheels with mud.
I'm Leo Voidy. I farm at Glenham, South Dakota. We've farmed about 3,000 acres, diversified small grain and row crop. The planter I'm sitting on here today is an old 7,000 8-row, 30-inch John Deere. It's been modified to handle the no-till residue. Up front we've got single disc John Deere fertilizer openers that tend to cut the residue a little better than a double disc opener and disturb the soil less. They have a wiper wheel and a depth wheel that run along one side and kind of hold the dirt back down and keep the mud from rolling up and mudding up the rest of the planter. We kind of have them positioned so they're 2 inches off to the side of our seed openers, and they do actually cut the residue ahead of the Martin row cleaners, which are kind of a double wheeled type of affair that run right ahead of the seed opening discs.
Coulters are recommended only for use in sandy or lighter textured soils. This is due to their potential to throw mud and ball up the gauge wheels and or closing wheels in heavier textured soils. Select coulters that'll do the least amount of soil disturbance. Remember to set the coulter depth approximately 1/4 inch shallower than desired seeding depth. This allows the seed openers to place the seed into firm, moist soil. Depending on row spacing, operators may choose to use a single residue manager versus the common paired residue managers used by the majority of no-tillers. Examples of single residue managers include the Groff and a residue manager fertilizer opener combination manufactured by Kinsey. Single wheel residue managers are also available from other companies.
Some of the features on this particular machine are we have a Groff residue manager on the front. We're running a single wheel. The main reason we're doing that is because we're running 22-inch corn, and with that narrow row spacing, we tend to plug up in between the rows if we run two.